So, two different things we can use to classify. One of them is degree, and one of them is number of terms. Now, when you look at this particular polynomial, the degree is found. It's the exponent. That is the degree. So this is a third degree polynomial. If you were to touch it with your fingers, you would get burned. Also fairly dangerous in a dark alley unless that person's your friend. Okay? Because then you want them on your side. Okay. Some people use it. Okay. This value right here will come in handy in a while. We call it the coefficient. So when you hear me use that term coefficient, I'm referring to that number. It's the multiplier on the term. Now the terms that refer to degree, the ones you're familiar with already. So a first degree polynomial would be called a linear polynomial. A cubic would be a third degree. A quadratic would be a second degree. A constant, well, this would be your 0th degree. And that's what we talked about with x to the 0. That's just a number, right? 17, something like that. Which one is this? Is this linear, cubic, quadratic, or a constant function? This is definitely cubic. Then we can classify by the number of terms. So, a monomial, that's a polynomial that has the disease mono. Or it's a single term, whichever one of those two. Trinomial, so this would have one term. This one has 3 terms. This one has 2 terms. Guess what? We run out of cool names. And so we start calling them polynomial of 4 terms, polynomial of 5 terms, polynomial of 16 terms. Okay, but we run out of cool terms. So which one is that? How many terms do we have here? We got 1. This is a monomial, right? 1 term. 8x to the 3rd. Okay, standard form. Standard form means decreasing order of exponents. Is this in standard form? No, it's not. Decreasing. So we have to start with the highest exponent and go all the way down to the lowest exponent. Well, that just got rid of B and C really quickly. Which one starts with the highest exponent and counts all the way down to the lowest? That is choice A. Right? Decreasing order of exponents. So let's classify this one. Letter A. Linear, cubic, quadratic, constant. Linear, cubic, quadratic, constant. It is cubic. That's true. You decide the number of terms. which term? Trinomial, binomial, monomial, or polynomial in 4 terms? Trinomial, right. This is a cubic trinomial. Cubic trinomial. Because there are 3 terms for those of you wondering. 1, 2, 3. That's how I got my choice there. Okay. Go. Question 3. Several of you are realizing that these were like terms and we could add them together. So what is 2 plus 7 minus 3? So the standard form answer was pretty simple. It was not a complicated polynomial. And how would you classify it? Cubic, monomial. Right? Degree is 3. But there's only one term. Several of you got that too. Okay, off to the side on question 3, I'm gonna write some notes down here. I'm gonna label these graphs 1, 2, 3, and 4. So make sure you write these graphs down. They're going to be extremely generic looking polynomial graphs. Super duper fancy about these, but so nothing tremendously fancy about them other than the shape. So make sure you draw something that looks just like this for your notes. Okay. The next thing we need to talk about, which goes with the next question, is something called end behavior. What they want to know, what's going on the far right side of the graph, and what's going on the far left side of the graph. That's really what we're trying to get at here. So if we look at graph number 1, what's going on the far right side of the graph? Would you say that it's going up or going down? It's going up. Now I'm going to abbreviate REV for right end behavior. Right end behavior. My abbreviation okay? Makes sense? Okay. What is the left end behavior of this graph? Would you call it going up or going down? Going down. So what do you think on graph 2? Is the right end behavior going up or going down? All right, so definitely down. And what about your left end behavior? Going up. What about my right end behavior on graph 3? Up. How about my left end behavior on 3? Now, I don't know if you've noticed this, but every single time I go to a new graph, I'm finding the right end behavior first and the left end behavior second. There is a real reason, which you'll see in a little bit, of why I'm doing that. You need to program your brain to find the right end behavior first and the left end behavior second. No. Right end behavior first on number 4. What's my right end behavior on number 4? It's going down. And how about my left end behavior? Down. If you look at question 4, look at question 4. Look at the multiple choice answers. Those are the only 4 possibilities. Okay, so how do I decide what the end behavior is when I'm just looking at this equation? First of all, is it in standard form? That's the question I ask myself at the beginning, and if the answer is yes, check, then I move on. If it's not in standard form, put it in standard form. All of the information you need is right here in that red box. This is called the leading term. I will abbreviate that LT. Hopefully that makes sense. What's the important information in that leading term that I need? Well, first thing I need is that number right there in the green. That's called the leading coefficient. What do you think I'm going to abbreviate that with? Oh man, you're so good. LC. Should have abbreviated ELSI. Never mind. I also need the degree. So the leading term holds the 2 pieces of information that I need. You will need to find the right end behavior first. So how do I do that? Well, we need that leading coefficient. So the leading coefficient is going to take on one of 2 different values, either positive or negative. Positive or negative. If the leading coefficient is positive, then the right end behavior is up. I hope you're writing this down in your notes so you can use it on your test. If the leading coefficient is negative, the right end behavior is down. Okay, so our leading coefficient here was -3. So which category did that put me in for the right end behavior? That puts me down for the right end behavior, which means we just got rid of those two choices. Do you realize that crossing off those two choices is a good way to give you a little bit of partial credit in case you get this thing wrong? Okay, next, the degree. The degree is either going to be even or odd. If the degree is even, then that means that the left end behavior is equal to the right end behavior. In other words, they are the same. If the degree is odd, then the left end behavior is what would be a good word? Opposite. I always think it's cool that OPP and ODD kind of look the same. Odd degree, opposite. Okay, so we have a 9th degree polynomial. Is that even or odd? That's in the odd category. So that means that the left end behavior is opposite of the right. We can make our choice out of the two remaining choices. So we start out by making sure it's in standard form. We find the leading term. We identify the leading coefficient and the degree, and we go down this path of finding right end behavior first, left end behavior second. Hopefully you have that written in your notes as we move to question 5. My leading term is 7x to the 9th. I guess I should have asked you if it was in standard form. It is in standard form. Your exponents do go in decreasing order. So, what do we know about the right end behavior? Since we have a leading coefficient of 7, positive 7, and a degree of 9, what is the leading coefficient telling me? It's telling me up on the right. And the odd degree telling me opposite. Leading coefficient telling me up on the right, odd degree telling me opposite on the left. Okay, question 6, yours. Go. Question 6. Is it in standard form? If so, identify your leading term. Pick off leading coefficient, degree. it's a second semester Algebra 2 question. I said, I know she's going to fire back. Remind me what that means. Okay. So we got leading coefficient of what? 9. Degree equals 6. Okay. Leading coefficient tells me my right-hand behavior is? Come on, it's a positive number. What's that telling me about the right? Up. So I'm immediately getting rid of B and C. The degree is even, so what's that telling me? Same as the rights. This question is definitely on the up and up. Okay, on question 7, ignore the second part of the question, so we're not answering this part of the question. I just want you to tell me what the end behavior of the graph is. Find the end behavior on question 7. Somebody's got a microwave in here. Oh my God. It actually does. I used to have a classroom that was over by, it was in the math hallway, but the fumes every day from the cafeteria would come in my classroom, so it was like torture. It was horrible. Well, yeah, there were definitely a couple days like that. Most days it was pretty good. Okay, so let's see here. We're looking here. We got a leading coefficient of 2. What does that tell me about the right-hand behavior? Up. Okay, so we can immediately get rid of those 2. We've got a degree, which is 3, which is odd. What does that mean about the left? Opposite. So down on the left, up on the right, choice A. How about number 9? You would need to know a little bit more information, which we're not going to focus on right now. Okay, you got your leading coefficient of -5. What does that tell you about the right-hand behavior? Down. Okay, odd degree. It is opposite. So, some polynomials are up and down. Depends on if they're having a good day or a bad day. think that's enough for today, quite honestly.